Blackboard real quick and look at the spec sheets for the 1N914. As I use the right password. Okay, so Blackboard, then we'll go to our slide drive. C120. Then we'll go to data sheets. And then we're looking for the data sheet of 1N914, which is a small signifier, which means it's designed to switch extremely fast. It's got very low capacitance, but the current rating on it's going to be real low. So it's not a rectifier diode. Rectifier diodes usually are set up around 60 to 50 hertz. So we're looking at this guy right here. This is our peak reverse breakover voltage, repetitive reverse voltage. So if we're putting an AC signal on that, that would be considered a repetitive voltage, right? And of course, if we put DC on it, it's definitely a repetitive voltage because it's there all the time. So we should expect this thing to break over a little above 100 volts, right? Probably is going to be greater, should be greater, but it might. And of course, what we do when they build a 1N119, there's no way in the world they can guarantee that all of them break over at exactly 100 volts, right? Does that make sense? But they're all guaranteed to be able to handle at least what? 100 volts. So we could probably put one in here and it'd break over at 115. We might put one in here and it'll break over at 110. Right, you understand? But all of them are going to be what? Above 100 volts. So what we're doing is, y'all see the circuit. We modified our voltages. What voltages are we going to use? So the breakover voltage is 100 volts, and they just only wanted us to put what on it? 5, 10, and 15. So what did I tell you we was going to use?
30, 60, 100.
30, 60, and 100. Okay? So this is why we're doing it with a team, because we're playing around with 100 volts. You know, DC. DC is slightly more dangerous than AC. Do y'all know why? For us getting electrocuted. Why is DC would be more dangerous? Why would high voltage DC be more dangerous than high voltage AC? They're not. They're both dangerous. Well, high voltage, your muscles are controlled by DC. So what happens is that we call it let go current, which means DC. If you get into a high enough DC, you're not going to be able to let go, and then you're going to start getting shocked, and you're going to start sweating, and your resistance is going to start doing what? Going down. AC though goes to 0 120 times a second, so it does go to 0. So it might knock you off, it might knock you out, right? But you have a more chance of getting out of an AC circuit than you do a DC circuit. So that's why it's slightly more dangerous, because it does not drop to 0. Now you get into high voltage AC and it's changing polarity real fast. And, by the way, if you see somebody getting shocked, don't reach up there and grab them. Right? Knock them, kick them, huh? Plus, yeah, it's 120 volts. We got into 120 volts. We got 120 volts DC. It might grab us and do what? Hold on. Yeah. But it all depends on how much current. What you're doing is you're overriding the current pulses coming from your brain, right? As soon as you override those current. Now AC, as far as it's also very dangerous if it takes a path through your heart. That's when AC really gets dangerous. And why is that? Because your heart tries to beat at the rate of the AC. Your heart cannot beat at 60 times a second. Mine beats 60 to 70 beats per watt per minute. And AC is going to try to make it beat what? Yeah, 60 times per second. So you go into fibrillation. And what that means is your heart and your valves are out of sync. So when your heart's beating, your valves are, instead of your valves are closed when they're supposed to be open and open when they're supposed to be closed. And you're not, even though your heart's beating, you're not creating any blood pressure. So you don't have any blood flow through your body. So what's going to happen if you don't get back in sync? It's strangely enough, how do they get it back in the sync? Shock you again. Yeah, but instead of being a frequency, it does what? It hits at one good time. And everything pulses at that time, and hopefully it gets you back in sync. Clear. Okay, so we're gonna do voltages. We're gonna do what? What's our voltage we said we was gonna do? 30, 60, and something over 100. The last one is going to be whatever it requires to break it over. Okay? And then I'll show you how we're going to modify our chart in there so you can draw the breakover side. So we'll just have 3 dots on our breakover side, but we should be able to see a breakover. Okay?